Okay, time to test these theories. So, I've got the LED plugged in, I've got the anode of the blue connected to this red wire, I've got the cathode, which is a common cathode, connected to this blue wire. So now I've got the 6 volts in the power supply and I can connect the cathode. However, like we said earlier, we need a resistor, and we need the resistor to resist off whatever voltage it was. So if I just get these pieces of paper back, we've got the 6 volts, we want to pass through 30 milliamps through, which means there's a total resistance in the circuit of 200 ohms. Of that, the LED itself wants 3.4 volts and its theoretical resistance is 113 ohms. Therefore we need to drop 2.6 volts before it gets to the LED, or well, in fact an hour after, and the resistance of the drop needs to be 87 ohms. So now if I was to get a resistor that was 87 ohms and just push it in here and add it to the 6 volt circuit, we should get the exact voltages and amperage and resistance according to the calculations, which would be a 2.6 volt drop on the resistor and a 3.4 volt drop on the LED, therefore powering it and allowing things to go as planned. So I need to get an 87 ohm resistor, and I suspect that it's not going to be so easy, but let me see. So as I expected, I don't have an 87 ohm resistor, but that's okay. We can use a similar resistor. I've got 82 ohms. So 82 ohms will do pretty good. We'll almost be there. I mean, and in reality, the exact resistance, isn't critical anyway. A few ohms out won't make any difference. Anyway, so I'm just going to check the resistance to make sure it is 82, because with cheap resistors sometimes it can be out a bit. Right, this is bang on 82 ohms, okay. So, what I'm going to do is put the resistor in, so the 82 ohm resistor. 82 ohm resistor, let's push this in somewhere. In series, of course, with the LED, according to our plan. So now, if we wanted, we could actually work all this back out with 82 ohms. So if we were to change the 82 ohms, then these things would also change. But it doesn't matter too much for now. Let's just go with it. And you'll see that the results are approximately as I pointed out in the calculations. So 6 volts, and I'm going to power this, and it should power nicely. Okay, so it's powered, we're using 6 volts. And now I'm going to prove to you that things are working the way we wanted them to work according to our calculations. So, where should we start? Well, to start with, the fact is that it's not burnt it out and it's not underpowered it is a good sign. So I'm going to try with some voltage tests to start with. So according to our calculations, the input voltage, well, not according to calculations, but the input voltage will be 6 volts. So let's just check this to start with. Of course, it's good to know. Yep, exactly 6 volts, so we're good there. The next thing we'll test is the LED voltage. Now, according to the calculations, the drop across the LED will be 3.4 volts. Now, of course, it may not be bang on, but let's see. 3.4 volts. It's 3.41 volts, right? Now, according to our calculations, the drop across the resistor will be 2.6 volts. So let's try that. And it's 2.59 volts. Perfect. And therefore the drop across the whole thing will be 6 volts, which I don't really need to show you because you already know. Now, resistances, you already know the resistance of this resistor, and therefore, using Ohm's law, we know the resistance of the LED, and we've already calculated it anyway. Okay. So I've shown you the voltage drops, which is good. The next thing I'll show you is the amp value, or the current draw. So we believe, according to our calculations, that in each circumstance, because it's a series circuit, the drop will be, sorry, not the drop, the load will be 30 milliamps. So let's test this out now. I'll put my voltmeter, or my multimeter, into amp mode. And now I'm going to break the circuit, wire my ammeter in series with it, and it should be 30 milliamps. and there you can see 0.03 amps, which is 30 milliamps. Okay, so I hope you enjoyed the video. I mean, I certainly did. I loved making this video. I love all this sort of stuff, mathematics and whatever else. So hopefully you'll understand it now. I mean, you understood it anyway, but for those who didn't, hopefully you liked this video and hopefully it was helpful. I tried to present them in easy ways, even though I know it's not the easiest of things to explain, but hopefully now, having watched this video, you'll be able to select resistors for your own LEDs and use the knowledge in other circuits and stuff. So anyway, once again, I hope you enjoyed the video and thanks for watching. Bye!